Okay, test yourself 1A. In the given circle, 0 is the center, ACD is 65 degrees, and AB equals BC. This means it's a isosceles triangle. Name two right angles in the figure. Okay, well the rule is that if basically a triangle has one of its sides as a diameter, that means that this angle here is 180 degrees, a straight angle. This means that the other angle has to be 90 degrees. Okay, and also the triangle ADC has AC as the diameter, which means that this here will also be 90 degrees. Okay, so the name of the two right angles is going to be angle ADC and angle ADC and the angle ABC. So ADC and ABC. Okay, so what you can see there is ADC and ABC. Okay, next question is find the angle BAC. So the angle BAC is this angle here. Now remember, it's going to be 180. These two angles are the same, so we call them angle X. So it's going to be 180 minus 90 degrees is 90 degrees. 90 degrees equals 2x. X therefore is 45 degrees. So that one there, 45 degrees. Now we're on BAD. Now BAD, if we're just to put in our answer from the last question where this is 45 degrees, this is a cyclic quadrilateral, which means that all four sides have corners in the circle. Now if I add the two of these together, the 65 and the 45 together, I'm going to get 110. Now the rule is opposite angles, so 110 plus this angle here has to equal 180. So it's going to be 180 minus 110, and that will get me 70 degrees. Okay, so 70 degree angle. Let's find out. ADC, ABC, 45 degrees and 70 degrees. So we're correct there. Okay, next one. Find the measures of the angles marked by the letters in each of these circles. Well, what we got to see is that the two of these are on the same arc. Okay, so we see that angle A, we call this A and B. Angle A starts at A, ends at B. Okay, and so does the 35 degree angle, which starts at A, ends at B. So this means they're both 35 degrees. So A is 35 degrees. Okay. The next one is the next one is C is opposite the 110. And remember, when we add these two angles together, we need to get 180. So basically, C is going to be 70 degrees. And this one here, when you add 85 plus B, we're going to get 85 plus B is going to be 180 minus 85, and what we get there is going to be 95. So 95 degrees for B. Okay, the next one is the angle D. We can see that they both have the same arc. They're both standing on the same arc AB. But because this angle of 130 degrees is at the center of the circle and the other points on the circumference of the circle, it means it's half 130 degrees, which is going to be 65 degrees. Okay, just have to remember that I skipped part B down here, so I actually have to do part B of this question. Okay, but before I do part B, 1B, I'll just check out my answers. 35, 70 and 95. So 35, 95, 70. And angle D being 65 degrees, which is also correct. Okay, next one we're going to look at is 1B. Sorry about the confusion. In the given triangles, the marked angles are equal. So this one equals this one, and then finally this green one here equals the green one here. Explain why the two triangles are similar. Both triangles are similar because all three angles in each triangle are equal. So this so if we were to label them, okay, basically 1, 2, 3, 4, 5 and 6, you can say angle 1 equals angle 4, angle 2 equals angle 5, and angle 3 equals angle 6. Basically they're equiangular because they have the same three values for each of the three angles. Okay, now find the value of x and y. Now, the only two sides we have the same are the one that's between the dot and the green angle. So 8 turns into 12. So we're going to divide 12 by 8. And we're going to figure out how much larger the big triangle is than the small triangle. It's 1.5 times bigger. So the next thing we're going to do is we're going to multiply 7 by 1.5. And when we multiply 7 by 1.5, 7 is in between the red angle and the dot. So y is going to be equal to 7 multiplied by 1.5, which is 10.5. Okay, so y is 10.5. And now x, which was 6, now we're going to multiply 6 by 1.5 to find out what x is. 6 times 1.5 is 9. So x is 9 and y is 10.5. X is 9, y is 10.5. Okay. Next part of that. Question C. In the given diagram, the arrows indicate that the lines are parallel. Find the lengths of the line segments marked A and B. Okay, so this is a ratio question. So this green part here divided by the red part is equal to the same, if you will, these lengths, because there's two parallel lines, these lengths are getting cut in the same proportion, okay? So it's going to be equal, this is going to be black, and this part here will be blue. Okay, so green divided by red equals black divided by blue. So what we're going to get is 6 divided by A equals 9 divided by 3. Get A on its own. So what we can do is we can turn it upside down, so we get A over 6 equals 3 over 9. Multiply up to 6, and what we can get is A equals 18 over 9. A equals 2. Now we know that A equals 2. Now, what we're going to have to do next is we have to figure out what angle B is, okay? Or length B. Now, length B is going to be, you're going to colour in purple here. Length B is this one here, okay, and it's similar to length 7 if we're to have two triangles, okay. So if we draw two triangles, okay, what we'd have here is a red triangle which represents the smaller triangle, and a black triangle which represents the bigger triangle. And what happens here is basically the bigger triangle has a length of 8 because it's 6 by 2, and then it has a length on this side of 12 because it's 9 plus 3, and its size there is big. Now remember, these two triangles are similar because these two angles are corresponding with each other, and these two angles here are corresponding with each other, and this angle here is common. So if that angle is common, we'll call it with a dot. This angle is common. This one here is the same as this one here, and this one here is the same as this one here. So we can see that these are two similar triangles. Now this has 6, 9 and 7. Now what we can do is we can figure out how much bigger it is by dividing 6 turns into 8. So let's see how much times 8 is bigger than 6. So 8 divided by 6 is what we're going to do. 8 divided by 6 is 4 over 3. So it's basically 4 over 3 times bigger. So we're going to multiply 7 turns into B. So we're going to multiply 7 by 4 over 3. And when we multiply 7 by 4 over 3, what we're going to get is 28 over 3. So B is 28 over 3. Okay, so that's the lengths A and B. A is 2 and B is 28 over 3. So let's just check that out. And 9 1/3 is 28 over 3. Okay, same thing. Now, we're on question 2. Given the two similar triangles, the equal angles are marked. Okay, find the value of A and B. Now these are two similar triangles. Angle 10 is in between the yellow and the white one. In between the yellow and the white one is 12. So 10 turns into 12. So the bigger, this is a smaller triangle, and this is the bigger triangle. Okay. 9, which is in between green and white, and A is in between green and white. A turns into 9. Okay, and then B, which is in between green and yellow, what used to be B is 8. So 8 turns into B, A turns into 9, 10 turns into 12. So 10 and 12 are the only two solid numbers we have, so we're going to divide 12 by 10. It's 1.2 times bigger. So A becomes 1.2 times bigger to become 9. So that means if we divide 9 by 1.2, we figure out what was the original length. Okay, and it's 7.5 or 15 over 2. So A equals 7.5. Now 8 is going to become 1.2 times bigger when it turns into B. So we're going to multiply 8 by 1.2. And what we get there is going to be 9.6. B equals 9.6. Okay, so what's that question 2? Okay, so 7.5, 9.6, no bothers there, okay? Next question, which is part C. What we're going to do here is, in the given diagram, DE is parallel to BC. Find the value of X and the value of Y. Okay, so we can do this, we'll find out Y first, okay? So once again, we're going to do what we did last time. The black line divided by the red line equals the blue line divided by the green line. Okay, so it's going to be 12 divided by 4 equals Y divided by 6. Okay, we're going to cross multiply the 6 upwards, so we're going to get 6 multiplied by 12 is 72. 6 multiplied by 12 is 72. 72 divided by 4 equals Y. 72 divided by 4. And what we get there is 18, okay? So 18, Y equals 18. Okay, now that we know what Y equals, we're next going to do ratios. We're next going to do the two similar triangles, okay? So this one here, the small one, or the top triangle, and the second one, which is going to be the complete triangle, and then we're going to write down their lengths. So the length of the complete triangle is going to be 18 plus 6, which is 24 on this side, 12 plus 4, which is 16, and 12. On the other one, this one AD is 12, this one's 18, and this the length X. Both of them are similar, once again, because of that's a common angle. The red angles are corresponding with each other, and finally the green angles are also corresponding with each other. So that's how we know that they're both similar, they're equiangular. Okay, so what we're going to do next is we're going to figure out how many times bigger the big triangle is than the small triangle. So we're going to divide 24 by 18, or you can also divide 16 by 12, but you're going to get the same answer. And the answer to that is going to be 4 over 3. It's 4 over 3 times bigger. So we're going to multiply X when it gets multiplied by 4 over 3 turns into 12, because both sides are in between the red and green angle. So just get 12 and divide it by 4 over 3 to get your original answer. By 4 over 3. And what we get there is 9. Okay, so we're going to get X equals 9. So Y equals 18, X equals 9. Y equals 18, X equals 9. Okay, now we're on the next question. Question 3. In the diagram, L, M, and N are parallel lines. Okay, so they're parallel lines. They make intercepts of indicated lengths on the lines J and K. AB is parallel to J. Okay, so these two here are parallel. Write down the length of AB and write down the length of AC. Okay, AB, because it's parallel to J, will make the same gap as J when it cuts downwards. So AB is going to be 5, because it has to be the same length as from here to here, because it's the same slope. Okay, now AC is AC, we should have a length of 6, because AC is parallel, or is a continuation of the line K. and the first ones where they make intercepts indicate, so they're making equal intercepts because this 5 equals this 5. That means 6 will equal AC, which is also 6. So AB is 5 and AC equals 6. 5 and 6. Okay, next question. In the diagram, PRS is an equilateral triangle. Equilateral means 60 degrees on every angle. All 3 angles are equal. If PQR is 36, find QRS. QRS. Well, Q to R to S is that blue angle I just marked out there. It's going to be 60 plus 36, which is 96 degrees. Okay, so we're going to get 96 degrees for that one. Next thing. So 96 degrees. And then we're going to have to find PQR. So P to Q to R, this one here. Now, once again, remember, this is a cyclic quadrilateral. And in a cyclic quadrilateral, opposing sides must add up to 180 degrees. So it's going to be 180 minus 60, and that will give us 120 degrees. Okay? So that's 120 degrees. Okay? And now we're looking for QPS. So that's 120. And we're going to find this angle in here first, the small angle. Now the small angle is going to be 180 minus 120 minus 36. So 180 minus 120 minus 36. And what we're going to get there is 24. Because that equals 24. Now that isn't the full answer. What we're trying to do is, we know that this here is now 24. And we know this is 60. Going to add them together. 60 plus 24 equals 84. 96, 120 and 84. Okay. On a 3.5 meter ladder leans on a 2.4 meter fence. So 3.5 meter is here, from here to here. Leans on a 2.4 meter fence. Now this diagram's a bit on the misleading side, I think. 3.5 meter ladder leans on a 2.4 meter fence, and the other end touches a vertical wall 2.9 meters from the ground. Okay, I'm just going to redraw this because it's very much on the inaccurate side. So 2.9 around here. We'll have my 2.4 around here. Sorry, my fence is going to be really thin. Excuse me. And then we're going to have my ladder, which is going to go, it's going to be much closer than that actually, excuse me. So look, this diagram, to say the least, is pretty inaccurate, okay? So, what we're going, nonetheless, it's still a triangle, okay? So what we're going to do is we're going to draw a triangle. And I'm going to draw the triangle we're meant to draw a bit more accurately, okay? So this here is a 90 degree angle. The 2.4 is pretty close in length to the 2.9, so we'll put it up here. So this here is 2.4. This one here is 2.9. The whole thing here is 3.5. So from here all the way to here is 3.5. And I have to find out what x is. Okay, so what we're going to do first and foremost is we're going to figure out what is the length of the full triangle. Okay, so we break this up into two triangles, or two smaller triangles, which is what we usually do. This one here is going to be of length 3.5, this is x, and this is 2.4. The bigger triangle, sorry, that's not length 3.5 actually, because the full thing is 3.5, so I actually don't know what this length is at all. Okay, the next one here is going to be, this is 2.9 and 3.5. Now 2.4 turns into 2.9, so divide 2.9 by 2.5, And what we get is 2.9 divided by 2.5. We get 1.16. Okay, so it's 1.16 times bigger. Okay, this means that 3.5 is going to become 1.16 times smaller. So 3.5 divided by 1.16, and that will equal, we're going to round this off, 3.02. Okay, so this part here is 3.02. And if that's 3.02, this part here is going to be 3.02 of the 3.5. That will leave 0.48 remaining. Okay, so that will leave a remainder of 0.48. Okay. Now, next thing we got to find out is how far is the bottom of the ladder from the fence. Okay, so we have to find out what the distance x is. Okay, so we pretty much have all the information about the right hand side. Now we need to find the information about the left. So now that's 3.02, and we know that's 0.048, and it's 2.9 meters from the ground. Okay. So what we can do next is we can use Pythagoras' theorem to find out what is the length of the total length of the bottom. So we still need more information. Okay, so what we're going to do next is we're going to put Pythagoras' theorem. The hypotenuse is 3.5 squared, and we know it's a right angle triangle because the ground is level and this goes up. So it's going to be 3.5 squared equals what's that going to be? Now this isn't x. I'm just going to call this length b for the bottom. Okay, so we'll call it b squared plus 2.9 squared. B squared is therefore equal to, bring the 2.9 squared over, equals 3.5 squared minus 2.9 squared. So we're just going to get 3.5 squared minus 2.9 squared. And we're going to get 96 over 25. So b squared equals 96 over 25. B therefore is equal to square root of that. So we do square root, answer, and we'll just put in decimals, so 1.96. So b is 1.96 meters. Okay. Now this now introduces the fact that this is 1.96 for the full triangle. And as we learnt earlier, what we learnt earlier was that when 2.9 turns into 2.4, so 2.9 divided by 2.4, it's 29 over 24. So it gets smaller by a factor of 1.21. Okay. So guys, just going to double check that one more time, okay, because I just want to make sure I got that right. So what we're going to do is 2.9 divided by 2.4 gives us how much bigger it is. So this is 29 over 24 times bigger. Okay, so this triangle here is 29. If I multiply the small triangle by 29 over 24, that's how much times bigger it is. So if I multiply 3.02 multiply by 29 divided by 24, I should get 3.5. And I don't, I get 3.6, so I just made a quick error on that. So I'm just going to, I suppose, start this from scratch again. Well, not completely from scratch. Okay. So this here is 2.4. That's 2.9. 2.9 divided by 2.4 equals 29 over 24. So it's 29 over 24 times bigger. Now 3.5 divided by this answer will give me how big the other one is, which is going to be 2.896, so we're going to call it 2.9. So this 3.02 was wrong, it was meant to be 2.9. Okay, now that we know that's 2.9, we know that the remainder is 3.5 minus 2.9, which would be 0.6. So that's 2.9 from here to here, and from here to here is 0.6. Okay, now that's perfect now. Now, to find out what x is, 1.96 becomes, we're going to divide 1.96 by 29 over 24 to find out what x is, okay? So 1.96 divided by 29 over 24, we're going to make the number smaller, and what we get is 1.62. So x is 1.62 meters. Okay, let's hope this checks out. 1.6 meters. Okay, so that's 3C done. And now we're going to go on to 4A. Find the value of x and value of y in each of these circles with O as its centre. Okay, well, first of all, what we know is that this triangle here, or sorry, not this triangle, but this line starts at, this angle is created from A and B, and so is the angle at the centre of the circle, which is 80. Now the rule is that the angle that's on at the circumference is half that of the angle that's at the centre of the circle, so x is going to be equal to 40. Now this is a cyclic quadrilateral where x and y are opposite to each other, and they have to add up to 180. So 180 minus 40 gives you 140. So x is 40 and y is 140. Now this one here, the angle, this one here is based on the arc, we'll call it AB. This one here, angle x, is also based on the arc AB. This means x equals 28. Okay? 28. Now, another thing to notice is that these here are radiuses. This means that this triangle here is an isosceles triangle. Okay? And also means this triangle here is an isosceles triangle. So what we're going to get is that's going to be 28, and then we're going to get 180 minus 28 minus 28. It's basically 180 minus 56, which is going to be 124. This is a 124 degree angle. The opposite one is 124 degrees. So when we have a circle, or sorry, when we have an x like this, and I'm highlighting this region in here where we have 124, 124, these two angles are opposite to each other, so they've got to be equal as well, and the whole thing has to add up to 360. So it's going to be 360 minus 124 minus 124. So 360 minus 124 minus 124, and what we get there is 112. So 2A equals 112 because all it has to add up to 360. This means A will equal 56 degrees. So now what I know about Y is that it's so let's do that for a minute. Okay, I know that this here is 56 degrees. I know Y is an isosceles triangle, so if we get 180 minus 56, and that's going to give me 124. Divide 124 by 2 because both of these angles are the same, Y and Y, and what we're going to get is 62 degrees. So Y is 62 degrees and X is 28 degrees. So let's hope that works out. 62 and 28. 28 and 62, 40 and 140. Okay, now we're on 4B. 4B. In the diagram, VZ is parallel to YW. So these two here are parallel. this makes find WY. Okay, so what this does is it makes this two triangles similar. So red equals red, blue is going to be common, and green angle equals green angle because they're corresponding. Two reds correspond, two greens correspond. What we're going to do then is we're going to draw the triangles just to visualize. That's the big one. And this one here can be the small one. Now, what happens here is 9 is equivalent to WY. So WY we'll call the letter A. WY is A, and we'll figure out what A is. Phi W we'll call B, but we don't know what it is yet. And Phi X, which is the full thing, we're going to call C. So what we have is the number 9. The bottom here is 12, and 12 is equivalent to the 8. And then this 10 here is equivalent to B. So we can see that they're color coded now. So what we're going to say is that this is the large triangle, this is the small, they're equiangular. So 8 turns into 12, and to turn 8 into 12 you multiply by 1.5. So 12 divided by 8, 1.5. So A equals, the enlargement is 1.5. Now this means that A is 1.5 times smaller than 9. So divide 9 by 1.5, and what that will mean is A is 6. Okay, so the answer to our first question is going to be 6. Next question is Phi W, which is sorry, it's not B. Phi W is this is B plus 10. Excuse me guys, because B only goes from here to here. So this one here is B plus 10. We can figure out what B plus 10 is. So what we know is B plus 10 when divided by 1.5. When you divide B plus 10 divided by 1.5 will give you 10. Okay, so we're going to say is B plus 10 divided by 1.5 equals 10. Cross multiply to 1.5. B plus 10 equals 1.5 times 10 is 15. Bring it over to 10, becomes a minus 10. And B therefore equals 5. So B is equal to 5. Okay. So this makes this part here 5. Phi W, which is B, equals 5. This makes phi to X 15. So we're going to go for 6, 5 and 15. Let's hope we're right. 6 centimeters, 5 centimeters, 15 centimeters. Okay. Now we're on to 4C. Colin calculate the width W of the river by taking the measurements shown, then using similar triangles. What answer should Colin get for the width? Okay, so look, what we're trying to draw here is this here. There's a triangle with W, and he's got 6. So what he's got is 6, 4 and W here. Okay, so I'm just going to grab this here. So that's what he's looking to draw. Okay. Now, so what we can do here is bring this down and enlarge it for our own use. So this is the triangle we're going to be working with. It's going to be 16 across, 4 up, W wide, and this is going to be 62. Now, there's a big triangle and a small triangle. Okay, so what we're going to do is we're going to take out the small triangle, just this one here, and for the small triangle it's going to be 16 by 4. Okay, and for the large triangle, which is this one here, if we can Okay, so for the large triangle, which I'll just get rid of this here for a second. Okay, so the large triangle is this part here, and 16 plus 62 is 88, or sorry 78, excuse me. 78 meters is equivalent to the 16, okay, and 4 meters, which is the size of the small triangle, is equivalent to the W. Okay, so that's what we know. Now we're going to find out the enlargement of this, and the enlargement is going to be 78 divided by 16, because it's much this is a much bigger triangle, so we have to see how much bigger it is. So 78 divided by 16, and it's going to be 4.875 times larger. Now this means that W is 4.875 times larger than 4. So multiply this by 4, and we find out that W is 19.5. W equals 19.5. This is 19.5 from here to here. However, it's not the width of the river. Okay? Width W of a river taken by the measurements of similar triangles. What answer should Colin get for the width? Well, you should get 19.5 for the width from here. Oh, sorry, he doesn't get 19.5 for W, because W is only from here to here. So the W I got was from here to here, and to be honest, doesn't represent W at all. So we can just call this X. Okay. So this is an X. X is what I got. Okay. So I got X from here to here, and X's length was 19.5. Take 19.5, take away 4, leaves 15.5. The width of the river was 15.5. Let's see if we're right. 15.5. Okay. Next one we're on is question 5. Question 5. In the given diagram, DE is parallel to BC. Find DE. Okay. So what we're going to do is big triangle and small triangle. Okay. So the big triangle, which we'll do here, call this one the big one, ABC. And this one can be ADE. Now they're both similar triangles, like before. Black one, red, and then green. So these are corresponding angles, the greens and the reds, and A is a common angle, so they're both equiangular. The length of A to B is 8. This corresponds to the side of 3. The length from B to C is 9. This corresponds to the length of DE, which is the point of the question. We'll call that X. And finally, the length of 4, which is AE. We don't know what the length of, we know 4 is AE, but we don't know the length of AC. So all we got to do is figure out 8 turns into 3, or 3 turns into 8. Okay? So 8 divided by 3 is the scale factor. Okay? It doesn't break down anymore. So you multiply by 8 over 3 to turn the small sides into the larger sides. This means we're going to divide 9 by 8 over 3 to turn it back into X. So it's going to be 9 divided by 8 over 3. 27 over 8, or 3.375. So D is going to be 3.375, or 27 over 8. So let's find out where 5A is. 3 3/8, correct. Okay, next part, part B. A path up to the car park from the beach has a constant slope. Now we can just undo everything here for a second. Let's take all this away. Okay, so we're just going to try number B now. The path up the car park from the beach has a constant slope of 2 and 7. So that means every 7 meters across we go 2 up from the beach at the end of the car park. How high are the sand dunes in the car park? So what we're looking for is from here to here, basically trying to find out what X is. Okay, so what we know is it goes 60 across. So to draw a diagram of this, it's going 60 across and X up. So 60 from 57 plus 3 is 60 and X upwards. Now we know this slope of X over 60. Remember, rise over run is the slope. Rise over run has to equal 2 over 7. So if you just cross multiply the 60, X equals 120 over 7. 120 over 7 we're going to get 17.14. So it wants it to the nearest whole number, so X equals 17 meters. Okay, so that's a very easy question, just rise over run, very much like a geometry question. Okay, alright guys, next question. In this circle, the chords PR and QS intersect at T. Prove that the triangles PQT and SRT are similar. Okay, so first thing we're going to do is we're going to mark off both triangles in different colours. Okay, so I'll mark off PQT in yellow, and then I'll mark off SRT in red. Now it doesn't matter finding out which angles are the same, okay, and proving that they're rectangular. Now I'm going to label all the angles and go 1, 2, 3, 4, 5 and 6. Okay, now angle 3, and we'll write down the name of both triangles. Okay, so the name of both triangles are going to be triangle PQT, and this one here is going to be triangle SRT. Now in triangle PQT, angle 3 equals angle 4. Reason being is they're opposite, basically the X, opposite angles. Okay, the next one is prove that 2 equals 6. Well, you're going to see that they both actually are on the same arc. They're on the arc PS, because if you go across Q, if you go around the angle Q, you start at P and end at S. Likewise, if you go around the angle R, you can start at P and end at S. So angle 2 therefore equals angle 6. Standing on the same base. Angles are standing on the same arc. Angles are both standing on arc PS. Okay, next one, very similar to the last one. Basically the angle 1 is standing on the arc QR, and angle 5 is also standing on the arc QR. So basically the same thing. So angle 1 equals angle 5. Angles, now you can say they're located, angles are located, now you might add this in as well, angles are located on circumference and are both standing on the arc QR. Okay, so basically, therefore, both triangles are similar. Okay, now it goes hence find TS. Now because both triangles are similar, all that we need to do now is just draw them both out and compare them. Okay, so this one here, the yellow triangle, and then we're going to draw the red one. And we're going to see how to draw them out. Now, we need equivalent sides. So we said angle 2 is the same as angle 6. So the side in between 2 and 3 is 5. So let me see. Let's just draw this a bit more to shape. Excuse me. Draw this one a bit closer to its real shape to make things easier. Okay, there we go. Now, this one here is 5. So it's in between 2 and 3. Now I'm going to draw in between 6 and 4. I don't actually know what it is between 6 and 4, so I'm just going to call it X. Okay. The next one is TS. It's in between the angles 4 and 5. I'm going to call this Y. I don't know what it is. But the angles 4 and 5 are the same as 3 and 1. So it's going to be equivalent to the number 12. Okay. So we know that that's 5. Oh, sorry, we do know it's 7. Sorry, it says 7 for X, so this is 7. So this one here is actually is the size 7. So the red triangle is bigger than the yellow triangle by a factor of 7 over 5. So to turn the red, this means that 12, if you multiply 12 by 7 over 5, you find out what Y is, okay? So this is going to multiply 12, multiply by 7, divided by 5. And what we should get is 84 over 5, or 16.8. So let's see for 5C if the answer is 16.8. There it is there, 16.8. Okay, now we're on question 6. Okay, so question 6. Find the measure of the angles marked X and Y in each of the following diagram. Okay, so what we can see is there's two cyclic quadrilaterals. Okay, so I'm going to dot the one with red dots first. We can see that Y is opposite 95, so 180 minus 95. 180 minus 95 gives us 85, so Y is 85. Okay, so now that we know that Y is 85, we can next concentrate on the cyclic quadrilateral in blue. Okay, and we can see that the 85 is also opposite the X, so X is going to be 180 minus 85, because these are opposite each other as well in a different cyclic quadrilateral, and we're going to get 95. X equals 95. In this one here, we have three angles of a triangle. X is the third angle, so it's going to be 180 minus 58 minus 58, which is 180 minus 116, which will bring us to 64. This is 64. 64 is in a cyclic quadrilateral opposite angle Y. So 180 minus 64 will give me angle Y. 180 minus 64 is 116. Okay, so this here is 116. So X is 64, Y is 116. So let's see if we're right with this one. 116 is 64, 95 and 85. So we're correct there, okay? Next question. B. Sarah found the height of a tree by placing a 30cm ruler upright in the shadow of the tree. She placed the ruler so that the end of its shadow was at the same place as the end of the shadow of the tree. So she's aligning the tree, okay, based on a triangle. So if we put our triangle up, excuse me. So basically what we're looking at is something like this. So this is what she's doing. Okay. So she placed the ruler at the end of this. So placed the ruler at the end of its shadows was at the same place at the end of the tree. How high was the tree? Give your answers in meters. Okay. So we have to find out what h here is. Okay. So what we're going to do is first we're going to draw the small triangle. Small triangle is 0.3 and 0.85. The bigger triangle, which is representing the height of the tree, h is in blue because it corresponds to the 0.3, and the two of these together, 22.4 plus 0.85, gives me 23.23. So the red one is 23.23. It's obvious to see that this is the larger triangle. So we're going to see by how much. Divide 23.25 divided by 0.85. Divided by 0.85. And what we get there is it's a scale factor. We'll just keep it in a fraction form, 465 over 17. So if you multiply the small triangle by 465 over 17, you get the length of the larger triangle. So we're just going to multiply 0.3 by this number. So our answer here multiplied by 0.3, and what we'll get for the height of the tree is 8.2 meters. Okay, so h equals 8.2 meters. So let's see if we got this one right. 8.2 meters. Okay, now we're on part C of number 6. Okay, in the diagram ABCD is a parallelogram and AB is 60 degrees. Okay, explain why ADE is an equiangular triangle. Okay, so we're going to explain what this is. ADE is equiangular triangle, which means I'm trying to prove that all three sides are 60 degrees. Now, the first thing I'm going to notice is that this is 60, and we can see that this is a cyclic quadrilateral. This means the angle AEC is 120 degrees. Okay, so that's 120 degrees. So that's the first part done. Now the next part is opposite angles of a parallelogram. So we can see here is these opposite sides going from D up to 60. They're the same angle. Okay, that's what parallelogram means. They're parallel. It's the same angle. Okay. So what we're going to get here is this means that this side here is going to be 60 degrees. Okay. And because we know that this is 120, so we're going to the reason for this is cyclic quadrilateral, the first one. Cyclic quadrilateral, opposite angle of 120. And then we're going to know that the angle AED equals 60 degrees because straight angle basically. And then we can conclude that triangle ADE or ADC is equal to 60 degrees as opposite angles in a parallelogram. Okay, and this leaves angle ADE has to be equal to 60 degrees because 3 angles in a triangle must add to 180 degrees. So we have green, this one here, and finally ADE, this one here. All 3 of them are 60 degrees. This is an equilateral triangle. Okay, next one, 7a. In the given figure, let's make this slightly smaller. In the given figure, EC equals 9, AB equals 8, and BC equals 15. Find DE. Okay, so once again, it's just a case of drawing the big triangle and comparing it to the small triangle. So we're going to get the big triangle here, small triangle here. What we're going to get is 8, and we're looking for DE, so that's 8 corresponds to X. The next one is 15 plus 9 is 24. 24 corresponds to 9. Okay, and now we have enough because we know that this triangle, the larger triangle, is 24 over 9 times bigger. Okay, so 24 divided by 9, which is 8 over 3 times bigger. It's 8 over 3 times bigger. And this means that the number A is going to be 8 over 3 times smaller when it turns into X. So just divide 8 by 8 over 3. And what we get is the number 3. So X equals 3. Or DE equals 3. So let's check out the DE there. DE is 3 centimeters. Okay. Now we're on the second to last question. A, B, C are pegs on the bank of a canal which has parallel straight sides. C and D are directly opposite each other. So C and D are directly opposite each other. This means it's a 90-degree triangle. Okay. AB is 30. So AB is 30. BC is 140. And when I walk from A directly away from the bank, I reach the point E 25 meters from A, so that's going to be 25. I'm just going to put it in different colouring. Now, before I even begin, I just want to mark off the similar angles to each other. Okay, so these two are the same, and this one is the same as this one. They're actually alternate angles. Okay, because you can see the Z formed there. Okay, so we know which angles are the same. So this means that this 25, where E, B and C are, how wide is the canal? This 25 lines up with this, and I'll call it X. Okay, so basically 140 divided by 30 in the big triangle, big triangle divided by small triangle, same sides, equals X divided by 25. Multiply the 25 upwards, and what I'm going to get is 140 divided by 30, multiply by 25, and we're going to get 116 and 2/3, or 116.67 meters, or X equals 116 and 2/3 meters. Okay, so it wasn't too bad. Now finally, the last question. Two surveyors estimate the height of a nearby hill. One stands 5 meters away from the horizontal ground, holding a 3-meter stick vertically. Two surveyors estimate the height of a nearby hill. One stands 5 meters away from the other on horizontal ground. So two surveyors are estimate the height of the hill. One stands 5 meters away from the other. Okay. 5 meters away from the other, holding a 3 meter stick vertically. The surveyor finds a line of sight at the top of the hill and observes that this line passes the vertical stick at 2.4 meters. Okay, and the distance from the stick to the top of the hill is measured by laser equipment is 1,500 meters. How high corrected nearest meter is their estimate of the height of the hill? So I need to find out what x is in a nutshell. Okay, so there's going to be a big triangle and a small triangle, the usual. Okay, the usual setup. So what we're going to get here is our small triangle, which is 5 meters and 2.4 meters. Okay, our next one, and our next triangle is going to be x, and we only know x. Now what we can do is we can do Pythagoras' theorem to find out what this is here, from here to here. Let's call it y. So y squared equals 2.4 squared plus 5 squared, and then so we're going to get 2.4 squared plus 5 squared, Pythagoras' theorem, 30.76, so y squared equals 30.76, square root it, sorry, roots 30.76, and it's going to be 5.55. okay, so this is going to be 5.55 rounded off. Now if that's 5.55, then the full length is going to be 5.55 plus 15,000, which is going to be 1505.55. Now we know the scale, how much bigger the big triangle is than the small triangle. Now please remember, they're equiangular as usual, and blue and blue. Okay, so just please remember that they are equiangular, and the black angle is in at the end. So we're just going to divide 1505.55 divided by 5.55, and what we're going to find out is that the scale factor is 271.27. The bigger triangle is 271.27 times bigger than the small triangle. I had to figure out how much bigger 2.4 would get when it turns into x. So I'm going to multiply this answer by 2.4, and the size of the hill is going to be 651 meters. X equals 651 meters. Okay, so you can see it's 652 meters. I'll just recheck my calculator. I got 651. Now the discrepancy will obviously be down to how you rounded it off, so you won't expect them to be losing too many marks there, if at all any.